Hey guys, today we are going over special segments of a triangle. So this is the third section of our current unit. And what we're going to be focusing on is just a whole variety of different types of segments in triangles and their relationships. So how they relate to one another, the angles, and the segments that they form. So first, we have a midsegment. A midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. So we know that a midpoint is the point in the middle of a line. So it goes right through. Now we have that midpoint on the left side of the triangle. Notice it cuts it into two equal pieces. And then we have another midpoint on the right side that cuts into two different equal pieces. Okay. So the important thing about a midsegment is that it is parallel. So remember, this symbol right here, the double L, the double cursive L, is parallel. So they never touch. To the third side, and it's half its length. So if we're practicing with this, if we're looking at number 1, we know that ER is 18. So again, our first strategy is to put the information right into the figure. We want to find the length of OC. We know that that mid-segment is half of 18 because that's what our mid-segment theorem above tells us. So half of 18, so remember half is dividing it by 2, is 9. So the length of OC is 9. Now something that I pointed out in class is how do we know that OC is a midsegment? First, we would look at the sides, and there are no congruent marks there. There's nothing there telling us that O and C are midpoints of their sides. And I actually had, one of my classes had a pretty hard time explaining why we knew that OC was a midsegment. Well, we are told right here, we are told that OC is a midsegment. So, with important information, it's either given to us, okay, so it's stated right there in a sentence, or we would have to look for congruent symbols and make that determination on our own. With number 2, this is where we apply algebra to our geometry theorems. We know that OC is 24. We know that ER is 3x plus 12. So what we want to do is determine first what is the length of ER. We know that our midsegment is 24. We know that the third side of the triangle is double our midsegment. So if you're not quite sure how I know that it's a double, it's the opposite of this piece up here. If the midsegment is half of the side of the triangle, then the triangle is double or twice the midsegment. So that means the length of that third side is 48. So this is our equation that we're going to set up. So what you should do at this point is pause the video, solve this equation, and then you will see that x is 12. Okay? If you're not sure how I got 12, you're going to want to solve that equation step by step, just as we have since you learned it back in algebra. So that's what we know about midsegments. Oh, wait, hold on. We have one more example that we're going to talk about. Oh, hold on. There we go. Okay. So this problem number 3 has to do with equations, or I'm sorry, angles. So SOC is right here. SOC. Notice this is an angle. It's a symbol for angle. SOC is 3y plus 5. SER is 4y minus 2. Now, we know that these two angles, since the midsegment and the third side of the triangle are parallel, we know that these two angles are corresponding. Corresponding angles are congruent. So, since those two angles are congruent because they are corresponding, we set the two equal. So this is a great example of why old information that we've learned is going to keep coming back. And we have to make sure that we're learning everything as we go along. So as you solve, so go ahead and pause, work through this equation, and you will find that y is 27. Okay, so far we've gone over the midsegment of a triangle. Now we're going to go over 4 other types of segments. So perpendicular bisector. So if you're having trouble remembering some vocab, make sure you write it down as we go along. Perpendicular, 90 degrees. So it's a segment that is perpendicular to a side at its midpoint. So perpendicular, again, the stylus is giving me a lot of issues here. It's not calibrating. You want to make sure that's a nice right angle box to show that it's perpendicular. Then it meets at the midpoint, so it cuts that side of the triangle into 2 equal pieces. Angle bisector only tells us information about the angle. So a segment that bisects one of the angles of the triangle. So again, bisect, cut in half. Okay? If we're given an angle bisector, we know nothing about the sides of the triangle. For median, a median now only gives us information about sides. It is a segment that goes from a vertex to a midpoint of an opposite side. So again, it only tells us information about the sides. If we have a median, we know that it cuts a side into 2 equal pieces. Altitude is generally what we've learned to be the height. So we use this in area of a triangle. It may lie inside or outside of a triangle. So it's perpendicular, doesn't tell us anything about the sides necessarily. So if it's an acute angle like the first one, the altitude is on the inside. If it's a right triangle, the altitude is actually the side of the triangle. And then if it's an obtuse triangle like this guy, the altitude's going to be outside. Okay? So what you can do is you can practice 1 through 4. I'm not going to go over them right now. You can do them on your own, and then you can check them with me in class when you see me. Centroid. Oh, hold on. Centroid is where the 3 medians of a triangle intersect. So if we head up, closer up top, median right here, this guy. Remember, it cuts the side of a triangle exactly in half. So centroid is when the three medians intersect. The centroid is 2/3 of the distance from the vertex to the midpoint of the opposite side. So first, let's go ahead and draw in our medians. I'm going to color code it nice for you, the best that I can with this stylus. Okay, we have our three medians. Our centroid is that guy right in the middle. So it's where they collide, kind of like an asteroid. Okay, so the centroid, they collide in the middle. The centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So if we're looking at the blue median, let's say that the entire blue length was 9. That centroid, so here, let's make sure, there we go. The centroid is going to be 2/3 of the distance from the vertex, so up here, to the centroid. So 2/3 of 9, so whether you do it out or you do it with a calculator, it's going to give you 6. So now, what's left for the remainder? Well, if the whole thing is 9 and that piece is 6, down here is going to be 3. You might also notice that 6 is double of 3, and that can help you with this relationship.